started working with logs, and we were working with the properties of the logs and natural logs. You're going to need your calculator out for this fun part of our lesson. So the main goal for today is I'm going to start talking about solving with exponents. This is really one of the most important parts that we're going to do, so you can see it, visualize it, understand it, and recognize when logs come into play. So we'll start by something like this. Okay, how do we go about solving? So there are three properties that we talked about on Friday. One was when you have two things that are multiplied, you can rewrite it with addition. One was when you have two things that are divided, you rewrite it with subtraction. And then the last one was if you have an exponential power, if you have natural log or LOGs, you can take that exponential power and bring them to the front. Is that clear as mud? We're good? See that? Okay, so the idea is that you are trying to, in this case, solve for x. And when you have x as an exponent, this technique will work every time. Now, on a personal level, I like natural logs, LNs, but some people like LOGs better. And so we're going to kind of talk about how you can work them both. But if ever I'm trying to solve for x and I see x as an exponent, what I'm going to do is I'm going to utilize the properties that I know. So the first property is to say, look, I got an exponent where it doesn't belong. So I'm actually going to rewrite this in terms of natural logs. If I do it to both sides, have I changed anything? No. I have not. Now, you could also use LOGs, okay? But oftentimes when they give you problems, they start with LN, so, interchangeably, however you want to do it. So now that I've LN'd both sides, I'm going to look at this and I'm going to go, okay, so I know by my properties that exponent that I have up there can be rewritten. What would I do with that?
Move it to the front of the LN.
Move it to the front. Okay, so this whole thing gets moved to the front. I'm going to put parentheses around it because it's like one unit. Okay. Now, ultimately, my goal is to solve for x. So literally, I'm going to try to get x alone. Well, what should I do first? Divide by ln of 5? I would as well. So I would have 2x plus 1 equals the natural log of 7 divided by the natural log of 5. Super cool. Now what?
Subtract 1.
Subtract 1. So 2x is equal to the natural log of 7 divided by the natural log of 5 minus 1. And last but not least,
Divide by 2.
Divide by 2. Also known as multiplying by 1/2. Does that make sense? So to make it easier to work with in my calculator, does it make sense that I could multiply everything by 1/2 there? And it would give me the same answer as dividing by 2. You make that call however you feel. Typically, they're going to say solve for x, and they'll say give me 3 significant figures as far as your result. So this is where your calculator comes into play. You're going to plug all this stuff in and produce a 3 significant figure answer. Okay? See how rich I am. Oh yeah.
Did we get a different answer?
We shouldn't.
Oh, so it's the same,
You should.
you should get this.
Did you do logs, LOGs?
No, I was just wondering
Did anybody do
if
LOGs?
they were like a different.
Because you would log both sides.
So what's the point of having LNs and logs if you do
So,
the exact same thing, get the same answer?
Yeah, LNs are base E, it's just another base, where LOGs are base 10. So,
But if they have the same answer, would they, or if they're the same thing, would they?
why would they have both?
The same application?
Yeah, they do.
Okay,
It's just whichever your preference is.
okay.
Back in the day, I think I explained this yesterday on my little Zoom lesson, because yesterday was only A-levels that got on, so I did a bunch of problems from the homework. So, back in the day, before calculators, BC, that's basically how I felt. So, we would have tables of natural logs, like, so natural log of 1, there it is, natural log of 1 point whatever. And literally, we would, there's my answer, and then we would use that. So, I always had natural logs in front of me rather than LOGs. They never did a log table for us. So, I kind of naturally go towards natural logs,
Okay.
but they do the same thing. Yes,
Is there a reason why you spell out LOG?
I have no, it's a logarithm,
Oh, okay.
so LOG, that, I mean, I'm sure I could spell it if I worked hard at it, I'm sure, but we just use it as a, it's like cosine, we put COS,
Yeah,
yeah. And then natural logs, who wants to write all that out? So they use ln,
okay.
which is very weird.
But you said like, when you say, you could use natural log or LOG. Like,
Do I say LOG?
you do- Yeah,
Oh, I don't say log?
no,
Oh, that's funny.
you do sometimes, but I was just,
I just interchangeably call it whatever I wanna call it, yeah, okay, that's, no, are we surprised?
no.
No, me neither. Alright, so what do we get for a 3 sig fig answer here?
Point.
0.105.
0.105, is that what everybody's getting?
Yep.
You feeling good about it? Okay, so, I mean, the moral to this story is, if you ever have x as an exponent, you wanna get rid of it, you ln both sides, or log both sides, or log both sides. I don't know, that's really weird. Now I'm gonna look at that and go, how am I saying it? Okay. That's fun. Alright, 3 to the 2x equals 4 to the x plus 5. Solve for x. Have fun. Super excited about this math? Not at all. What'd you do to both sides?
ln.
ln both sides, yeah. So if I ln this side, did anybody log it by chance? Or log it? You did? Let's see how it works, okay? So we're gonna take the 2x and we're gonna bring it to the front. And the x plus 5 and bring that to the front. I put parentheses around it. Ooh, how do we do that? How do we solve for x? Good question. Huh?
Would you distribute?
I would distribute
Like
and,
X's on both sides?
and bring your x's off one side.
Factor X out.
Exactly. So you're gonna distribute this puppy through, so you have 2x ln of 3 is equal to ln of 4x and 5 ln of 4. If I distribute it, then I say, oh look, I can bring all my x's to one side and everything that doesn't have an x to the other side. Yes? So I would have 2x ln of 3 minus ln of 4 with an x equals 5 ln of 4. And what special thing happens on the left-hand side if I'm trying to isolate my x? What can I do?
Factor X out.
Pull that x out, factor that x out. Because that would leave me with the 2 ln of 3 minus the ln of 4 with a 5 ln of 4. And then how do I get x all alone? Divide by it, right? So x is equivalent to 5 ln of 4 over 2 ln of 3 minus the ln of 4. Now you can just use that handy dandy calculator and not the table that I would have to use. And you plug it all in, and that should give you a value. 3 sig figs. Is it, okay, I'm anxious to see how the log stuff, log stuff comes out. What are you getting for the answer for this guy? Is that what everybody's getting?
No, I
No.
didn't get that.
8.55, yeah.
Mhm.
So my book says 8.55. However, okay, so things that you might have to do to kind of make sure it's right. When you're plugging in your denominator, try to put parentheses around the whole thing so it doesn't think you're dividing by the first thing only and then subtracting that number.
I think I did that.
You think you did that?
I don't even know. I put all the numbers in right.
Ugh.
I don't know. I'm just gonna write that.
Just gonna go with it. So the example I have did the problem with logs, and it's the same answer. We did it with natural logs. Okay, I've got a good one, a thinker. Gonna make you think. It's a good thinker. Maybe it's a good thinker. All right, I can't even remember what it is from here to there. Okay, this ultimately wants us to solve for x. Whew. This type of problem is pretty prominent on an ACE exam. Sometimes they'll have a part I that kind of guides you into what you need to be doing, and oftentimes it doesn't. It's just like this, where it's like, oh, have fun. Okay, so for this problem, I am not able to ln both sides. It's not something equals something where I natural log both sides. Yeah, do you have a question? Are you, okay. I can't just ln and then distribute it all the way through and think that that's gonna work for us. So I have to be creative in my thought process. So what does this kind of, out of the box, what does kind of look like? Does it look like something we might have learned in, algebra? Yes.
Putting 2x under 3? Like making it a
Well,
fraction?
there's no negatives. There's no
Alright.
negatives, so I'm not gonna flip it down. If there was, I'd be flipping it down, but there's no negative. What does it kind of look like? It looks like a quadratic to me as well. What makes it, like, tell me if this was a quadratic, what would it look like?
Like x squared.
Like an x squared thing?
Yeah.
And then, okay, so let's not use x again, use another letter. What do we got? A,
Yeah.
okay. So you would say I have 2, and then a squared. Are you guys cool with what I just said? Plus 7 times,
Times A,
why a? Can you tell me?
because you're trying to get just one variable.
You're trying to get one variable, right? So again, we're thinking outside the box here. And then equals 15, right? That is something, if I said, let's solve, you'd be like, oh, I can solve that, yeah? This over here, you're like, not so much. What are you doing, Ms. K, right? So what we're gonna use is this thing called substitution. We're gonna say, we're gonna make it something that we know how to solve. So you guys told me A. I'm gonna say, let A equal 3 to the x power. So A equals that. So if that's the case, I think I'm gonna leave this blank for a minute. I'll leave it blank. Plus 7a is 15. How do I handle this guy? 3 to the 2x. So what would that be in terms of a?
A squared.
Yes,
Because you just added it.
because you just are doing, like, so if a to the x equals a, sorry, if 3 to the x equals a, then if I square both sides, it's that. Does that make sense? So this is just a squared. So literally, when you see something that looks like that, you can go, okay, if I make it something more presentable that I am accustomed to working with, I can tackle this. I'm good. So let's go ahead and try to tackle this. I'd have 2a squared plus 7a minus 15 equals 0. It screams, I'm a trinomial. Bring me all to one side and factor me.
Yesterday when we had something similar to that, we ln'd it. So
Only?
it was ln 2 plus ln of 5x. So could you do the same
Only
thing?
if you don't have this 15 involved.
Alright.
Yeah, because the 15 puts a problem into the thing. Can we factor this thing? Is it
Yes.
factorable? What do we get? 2a
Minus 3
minus 3.
plus 5.
Okay, that's nice. How we feeling? Like that was doable, right? So what is a for this guy? A is 3/2 and a is -5. Everybody cool with that? So to start this problem off, I said solve for x. The problem is I solved for a because I used substitution. I like, let's make it something that's more presentable. So I don't want a, I want x. So how do I handle that? Yes?
Could you square it and then say equal to root 2 times x and then do ln on the side?
Yes, but you made it a little bit more, you went the hard road, you went to the bumpy road. Look at this. A is 3 to the x. We don't even have to square it. Does that make sense? So A, absolutely good idea. So we're going to take 3/2 is A, because we know A is equal to 3 to the x. So instead of A, we'll put 3/2, and that's equal to 3 to the x. Now this comes back to where I started this lesson. How do I solve for x that's in an exponent? I do what? I ln both sides, right? We just did that. So I'm going to ln both sides. Then what do I do? Bring it forward. So I have ln of 3/2 is x times the ln of 3. Then what do I do?
Divide.
Divide. Yeah, we're feeling good. So ln of 3/2 divided by the ln of 3 is x. And then what do I do?
Calculator.
Plug it right in my little calculator. So that's one answer. But we have another A, right? We have another A to work on. So does it make sense I could do the same thing? -5 is equal to 3 to the x. And then you do the same process. So what do you get for the first guy?
0.369.
0.369? Okay. And then let's do the next guy. How do I start to solve for x here? What do I do to both sides? ln it.
That's it.
What is ln of -5, if you don't mind plugging it in?
Error.
It's an error, yeah. It's an error. And let me show you why. If I was drawing, what is ln of 1 in your calculator?
0.
ln of 1 is indeed 0. Okay? And do ln of 0.5 in there for me. What do you get? So negative something, right?
0.693.
Okay. And then do ln of 0.25, which is closer to 0.
-1.3.
Yeah, you get a little closer down. And then again, closer down and closer down and closer down and closer down. So this graph, huh?
Is it an
It's an asymptote, yes. You will touch, I mean, you'll get as close as you can to 0, but never cross it. So that's indeed an asymptote. I like that. So you have this guy, which is going to get closer and closer and closer and closer. It's going to hit 1, and then it does this. So tell me, will natural log ever be a negative number? If I can plug in a negative number? No, it doesn't even go over there. It doesn't exist. Okay? So ln gets as close to 0 as possible. So you can plug any decimal between 0 and forward. But 0 doesn't work. So if you put ln of 0 in there, you get undefined, or whatever it says, error. So just FYI, if I ever come up with a problem that says an ln of a negative number, you can say, oh, I know, I'm not even going to have to do that problem. It's done, I'm over it, yeah. Okay? So what do you think? Outside the box, they do this most of the time on an ACE exam. They'll say, substitute y equals 3 to the x, and then do the problem. A lot of times they're going to kind of push you in that right direction. Once in a great while, they're going to say, solve, and have fun with it. And you got to remember, ooh, I should use a substitution thought process. Okay, so oftentimes it'll hold my hand and tell me, so just kind of keep that in mind. All right, how are we feeling so far?
All right.
We're feeling okay? We're not ready to jump ship yet? It's good to hear. It's very good to hear. Okay, so they've all been kind of nice. They've all been where I can kind of, well, they're not nice, but they've all been, they're okay. So far, they're okay. So let's do this. Oh wait, hold on, let me. Let me start a little easier. I want to start easier. You're welcome. That's just a nice way to go, isn't it? Yeah. I don't always, I'm not always nice, but this is a nice, I'm gonna be nice today. Okay. So, how do I solve for x here? I'm starting nice. That's unusual for me. So we're gonna start here, and I'm thinking to myself, natural logs have what base? E. LOG logs have what base?
10.
10. So I'm going to show you both aspects of this. Okay. The other day, I taught you how to take something that was in a standard form and make it exponential form. Does that ring a bell at all? Okay. I use letters. Log A, little b is x. You remember that? I went log A of b is x. And how did we rewrite this guy here?
A to the power of x
A to the power of x, so this to this,
equals b.
equals, so I gotta figure out a different way to make it like, so equals b, 'cause that made no sense, but the idea is the little guy to the power out here is equal to that number. So if I'm looking at this, what's the little guy that I don't see? What's my little a in that case? E, because we don't see it, right? So E. And then what's my little guy over here?
10.
10 and D. So same concept. You have E to this power is equal to this. So E to the third is x. And can you plug E to the third in your calculator?
Yes.
Sure. And that would be your answer. Okay. What is it? 20.08. Is that what I heard?
Mm-hmm.
Okay. Okay, same thing over here. So we're gonna go 10 to the power of 3 is x. 1,000, right? Are we feeling okay? Are we cool? So the idea is the little guy to that power. So sometimes they're not as pretty as this. Sometimes they're not as pretty as this. They're not concise where it's like ln of x equals stuff. So we're going to have to be creative in how to solve for the x. So it started nice, and now we're going to go full force and have a good time with this. Okay.
Ms. Kim,
Yes.
will they ever specify when you need to use ln versus log when it's, but you get two different answers for x?
If it looks like that, like log of ex is, because our bases are different. So this guy is base 10, so you are going to get a different answer.
But will it specify on the test which one to use?
It'll,
It says it in the.
yeah, it'll say it.
Oh, okay.
Yeah, it'll say it, yeah.
Okay, that's good, yeah.
I'm with you now.
Okay.
I'm with you now, yeah, okay. So, we're gonna start here. Okay. So, if I'm looking at this, I'm almost at a place where I started the lesson and I had two things and I put ln on both sides. Do you guys agree? Like I said, let's ln both sides and then we can kind of clean it up. The same kind of concept happens here. So if I'm looking at this, if I had ln of stuff equals ln of stuff, there's a technique that we can use every time it works. I'm not quite where I need to be. I have ln of stuff and then I have a 2 up front with ln of stuff. So how can I handle this first to make it a natural log and a natural log?
Put the 2 in the power.
Put the 2 to the power, right? So the first thing I do with this type of problem is I go, okay, is there a possibility that I can have just the word natural log and just the word natural log with stuff behind it? And in this case, I did. I was able to. So are we cool so far? Now, when I'm talking about natural logs, what's the little base that I'm working with? E's, okay? So for me to be able to get rid of the natural logs, a minute ago we stuck natural logs in, right? We used natural logs to kind of get the x out of the exponent. This one, I want to get rid of the natural log, okay? So the way I get rid of the natural log is what I say, well, I will sing it in a minute. We E it. Okay, so you E it. Okay, so anyway, so if I raise e to that power, and I raise e to that power, I have not changed it, because I'm doing it to the same for both sides, but they are kryptonite to each other, okay? They're actually inverses of each other, so they actually eliminate each other. E to the ln. Whenever an e and an ln touch each other, it just goes away. Okay, so e to the ln, it disappears, it goes away. I can show you why in a second. But it actually becomes 3 minus x squared, because I eat it.
Yes.
Eat it, thank you. Nobody would sing with me yesterday. It made me kind of sad. Yeah, I was the only one singing, and my husband's like, why are you singing that? So it made me sound even more exciting than I really was. So then, e to a power ln gets rid of each other, and what am I left with? It is indeed x squared. Is this a doable thing? Can I do this? Absolutely. So if I e both sides, also known as e it, yes. If I e both sides with my natural log, I'm good to go. So let's go ahead and solve for x here, please. So, if I look at the answers that I got, do you agree with me that when I solve for x squared, I would get 2 answers, right? However, look at the original problem. I just drew a beautiful graph of ln of x, and what did we decide about when we looked at the graph of ln of x? Can it ever be 0? No. Can it ever be negative? So if I took these answers that I have, and I went right back to the original, okay, is one of them not going to work?
Yes.
Which one?
Negative.
The negative square root one, right? Because right here, that would be a no-go. Does that make sense? I can't plug it in. So guess what? I can, without doing much work, eliminate that particular answer. And oftentimes they'll say, give me the answer, 3 sig figs or whatever. But if they ask for the exact answer, this is what they're looking for, okay? So sometimes they're gonna specify how many decimals they're looking for, or they're gonna say, give me the exact answer, and there you have it. Yes?
If when you do that, like on the exam and you're like, oh, well, it can't be the negative square root, if you just don't have the plus or minus there at all, you just write square root of 3 halves, would that still get you the point even though you don't have the negative?
I think
mean, the
so.
positive?
Yeah, because you're showing that, yeah. I
Okay.
don't feel like they're gonna look for you to say, oh, it's out of question, yeah,
Okay.
I think so. Yes,
Is that supposed to be a plus or minus?
okay, so the reason why it's not a plus or minus is because I can never plug a negative into the natural log. Remember that little drawing that I just showed you? It never goes to the negatives, it can never plug it in. So I can eliminate that negative one, it's gone. Does that make sense? Okay. So how do we feel about E in it?
So if we got a negative answer, but say like whatever was being plugged into the natural log was like
It makes it positive
makes
somehow?
it positive, could we still count that negative answer?
Yes.
Or do we have to go back and
The actual problem.
if the answer was like -3, but it was like 9 plus x?
Yeah, so let's let's pretend that this original answer had a 2 here for squared, right?
Yeah.
So if I took a negative in here and I squared it, and then I did 3 minus that, and it still is positive, that's okay. And if it's
Okay.
squared, that's okay, so I don't eliminate it. So you
make
do
sure-
want to go back and visualize what the actual first problem is, not when you start cleaning it, but what's the first problem.
Okay.
And see, and oftentimes it will have a simpleton ln of x in there where you can very much eye it and go, I can't put a negative in, that's out of the question. Once in a great while they'll have it where it does work, but for the most part they're going to see, they want to see if you understand that it may not work. Is that cool? Yes? Okay. Are we feeling good about this? Yes. Bless you. Okay, so let's do this guy. I guess the good news about this particular lesson is we don't test until Monday. So we have a lot of time to kind of go over these things and talk about situations and scenarios. So we have, once I'm done kind of teaching it all, then we'll kind of look at the problems, go through the problems, and fun. Okay, the only way that I can E it is what? If I have
Nothing in front
natural log
that
of
one.
junk equals natural log of junk, right? You guys cool with what I just said? Literally, you have to have an ln of stuff equals an ln of stuff. It can't be a string of ln's. It's an ln of stuff equals ln of stuff. Are you guys cool with what I just said? So, knowing that, can I eventually make this become ln of junk equals ln of junk? So what do I have to do in order to condense this to make it ln of stuff equals ln of stuff? So kind of think about the properties we talked about on Friday. How can I condense it to make it something that I can E it? Okay. The front, that's a good first step. Then I went, and then I go, oh, there's a subtraction, which means I can rewrite it as
Division.
a division. So go ahead and clean this left-hand side up for me. Start cleaning it up a little bit. And then I recognize, oh, that's pretty cool. I can rewrite this because the subtraction means division. How do we feel? Decent? Now, I want to get rid of the natural log, so I do what?
Yeah.
You do what? Yeah. Yeah, okay. Nobody wants to sing with me. All right, it. Connell's. Thank you. So we have x plus 2 squared over x equals 2x minus 1. Is this something that I can start to solve for x with? This goes back to algebra 2. I got a lot of fun to have. I multiply both sides by x. I FOIL this guy out. I combine like terms. And I don't know about you, but that seems like a great fun. Are we doing math? Are we mathing, right? Yes? Feeling good? No? That addition stuff, that just rocks our world sometimes, I know. Is it factorable?
X minus 4, x minus 1.
No, because that'd be plus.
No.
Darn it. So what do I have to do if it's not factorable? Quadratic.
Then my calculator lied to me then.
Oh, did it?
It must have. I can try.
Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a.
Oh, because it's minus 4.
Yeah. All right, what did you get for your x values? 5